Calculus Review Section 7, Factoring Power Functions. This is something we use all the time. Most of the time, it's pretty easy, but whenever the order's higher than 2, there's just a level of difficulty added that is tricky. So, let's start with like the easy ones. If we have something like x squared minus 6x, what do I want to do? Minus 7. And we want to factor this thing, and there's many reasons we'd want to factor this thing. So like to check for holes, or, well, let's just factor it. Kind of the two ways that are most commonly seen here at Liberty is you throw your base in the bottom, -6, that's the B term, the A coefficient is 1, the B coefficient is -6, the C coefficient is -7. It's like ax squared plus bx plus c, that sort of notation. We throw the -7 in the top, and we go, what multiplies to this and adds to this? So multiplies up here, adds to that. And it turns out this one's pretty easy. -7 and 1, those multiply to -7 and add to -6. So that's one way. The other way that's very commonly seen here is the one where you're like x squared and -7, and you're like, okay, so I know I have an x and an x, because that's what multiplies to x squared. So I already figured out those about my terms. And then there aren't that many combinations that multiply to 7, because 7's a prime number. So 1, 7, -1. So 1 and -7, or -1 and 7. So I should just try one of those. So I'll try the right one. And if I do this, I get x, and I get -7x, and those add to -6x, and I've done it. So just a few ways. You can just do this in your head in a lot of cases, and that's fine. But yeah, when we factor this, we get x minus 7, x plus 1. -7 plus 1, x plus 1, x minus 7. We got it in all the different cases. So let's look at examples where this is useful in calculus. Example 1, finding zeros. X squared minus 6x minus 7 equals 0. Well, it turns out we'd have to like try numbers, guess and check to figure out where it's equal to 0, or, let's just show the bad way. The way a lot of people solve this problem is they go, oh, x squared minus 6x equals 7. And then they're like, oh, square root both sides. X minus 6 equals √7. This is demon math. Ooh, this was okay, but not useful. And this is really bad. No. Don't do that. So when you're in this case, always try to factor. So we factor x minus 7, x plus 1. And now we can find the zeros. They're 7, or what we plug in for x that gives us 0 in this parentheses. Or I can set this one equal to 0 and get x equals -1. So that's a really useful spot. There's also the example like this. X squared minus 6x minus 7 over x plus 1. And we're trying to simplify this expression. Well, it turns out, because we have x minus 7 times x plus 1 over x plus 1, and that these are equivalent expressions, we can kind of cancel these out, and we can say, hey, this nonsense here is just x minus 7, the line, as long as x is not equal to 1. So it's a way of simplifying something that's kind of janky looking to being something that is nicer looking. We just know that this line goes through -7 down here, and like cruising up at a slope of 1, and then we get to the point 1, and we're like, hole, and then we keep going. That's it. All right, so that's all like the applications. Let's look at some more heated examples. So this is the cubics can be brutal to factor. So let's look at an example of a cubic and try to pull out its parts. And I'm just going to put this in the next video.